Hello friends, welcome to our channel TurtleConnect.com. In this session, we will discuss about the inheritance, okay, and equivalent to inheritance in JavaScript. So, how can we achieve object-oriented programming concepts inheritance in JavaScript, and what's new features in ES6 feature to achieve this? Okay. So, first of all, what is inheritance? See, if you know about the OPS concept, you will familiar with the inheritance. Basically, inheritance is something you get from parent. That means if you are a child and you want to access some properties from parent, okay, so you have to inherit their properties from them. Okay, that means if you see like A have some feature, okay, feature 1, feature 2, okay, and B is a child of A, and he wants feature 1, feature 2, and he has his own feature 3. Okay, so we don't have to repeat this one inside, so the code will be duplicate. For that we use the inheritance, so that we will inherit the feature of A here, and A will have this one. Okay, so this is called the inheritance. Okay, so how can we achieve? So there are three different types. Okay, and fourth one is using the schema scripts 6 version which have class. Okay, so we will write basically here. You can see we have the 4 types by which we can achieve the inheritance. Okay, this one is pseudo classical. Okay, second one is prototypal, and third one is parasitic inheritance. Okay, and fourth one is if you are using a class, then you will have to use the extends. So this is basically your ES6 feature. Okay, and these all will be used with previous versions as well, with latest as well. Okay, in ES6 or earlier with earlier E6. Okay, so in both you can use this one. So we will discuss one by one these all things. Okay, so let's suppose we will have a function point. Okay, so we have a function point. Okay, and inside this we are passing two points x and y. Okay, so we have this dot x here, which will have x, and this dot y will have y. Okay, and now we will have another method here, add. Okay, so what this will do, this will basically add x plus this dot y. Okay, so you can use here function as well, or you can use this dot add. Okay, okay, so this will add this x and y and will return. Okay, so this is the simple function which has two parameters x and y, and it has a function method which will return the sum of this. Okay, so if you console this one, log with point, you will get the function, and inside you will have name point. Okay, that is the name of your constructor. Okay, so every constructor has the same name of the class. You can. Okay, so this is the prototype chain. Okay, from which this is inheriting. So basically this function is inheriting something, some behavior, some features from inbuilt method function. Okay, so if you will write this one, you will see, you will get like this function f. Okay, and this has also a prototype chain which will point to object. So if you will write like this, then you have an empty object here. Okay, that means this is the inheritance chain. Okay, so this point is also getting some feature from object, then to the function, and to this. Okay, so this is the prototype chain in JavaScript. Now we will go for further that we have another function point 3D. Okay, and we will take the three parameters here, x comma y comma z. Okay, now what we want these all features to be inside this point 3D. Okay, so you don't have to write, for that you have to inherit this point here. Okay, so what we will do, we will just use the first, we will have z here. Okay, so we will have z here. Okay, so we are basically using this pseudo classical method to inherit here. Okay, pseudo classical method. Now what we will do, if you will console this. Okay, so what you will see, you will have a prototype of function. Okay, that means it is accessing its features from function and its constructor name is point 3D. Now what we will do, we will call the point here directly and we will find the feature of this class with parameter x and y. Now you can see we have the same thing here right now. Okay, now if you want to override this method with this one, okay, now you will have another this jet here. Okay, you are just using the polymorphism concept to override this add with this point 3D add. Okay, okay, now what we will do, we will create an instance. Let 3D equal to new point 3D, and we will have to pass some value like 2, 5, 7. Okay, now we will console something D. So what you are getting right now, you can see that this D is now an object. Okay, this is a function, but now this is D is now an object. So D is now an object. Okay, and its prototype chain is inheriting with point 3D, which is a function. That means if you will write this, you will get this function. Okay, that means this function prototype is inheriting inside this D object. Okay, that means that shows D is a instance of point 3D. That is true. Okay, now what we will check, it's a instance of point false. That means it's only the instance of this one, but it's not the instance of point. We are getting these two parameters here inside D, okay, but this is not the instance of point. This is only the instance of D, because if you console the D, you will see the prototype pointing to the 3D. Okay, so now we will move for next. We will have consoling here D right now first. Okay, so we have a object here with add function, and functions is prototype is function. Okay, we are getting x and y with the help of this one point dot call. Okay, now if you will add this, you will get 14. That means 2 5 7. Okay, that means 7 plus 7, it is 14. Okay, this is simple one. Okay, now what will happen if you have some method here point dot prototype dot get, you can say area. Okay, return, let's suppose this will multiply. Okay, so we in the area we are multiplying this. Okay, so we have a method in the prototype of point. Okay, not directly in this point, but in the prototype of this point. Okay, so what will happen if you will try to access get area? So you can see that get area is not a function. That means even after doing this call with the point, we are not getting the area. Okay, that means you are using this object x and y inside this one, but you will not get the area if you will define the prototype here. Okay. So what you will have to do if you are using the pseudo classical method, okay, then what you have to do, okay, here before creating the instance, okay, so you have to do point 3d dot prototype equal to new and point. Now what you see that your output is coming with two values. That means these two, x into y. That means 5 into 2. You are getting 10. If you want this prototype to return all three, then you have to redefine with the override with the point 3d with z means 70. Okay, so what is here first, you can see what's happening here. It will not give 70 right now. What will be the issue, you can see here. See, if you will console now d, what you are getting, you are getting the instance directly of point here, not of point 3d. Before doing this, you were getting point 3d instance. Okay, but after doing this, you are able to get area. Okay, but with 10 only. That means it is accessing this this one. It is not overwriting this one, this area. Okay, why this happening? Because The constructor of this point 3D is pointing to the point, this point. Okay, that means if you will do like this, d dot constructor, and if you will give some value 4 into 6, see what happened. It is giving you 24. That means why 24? Because constructor having two parameter is here your parent one, that is this one. So it is using this one and it is giving you the output of this one. Okay. Now what will happen if you will have three value here? So there will be no any change because this constructor is pointing to parent one. So there will be no change. So how can you change this one? For that you will have to write like this: point 3d dot prototype dot constructor equal to point 3d. Okay. Now if you will console this C, you will see that you are getting the point 3d. Okay. That means you are getting the value of point 3d1 constructor. Okay. Now this constructor is pointing to point 3d. Okay. But the method get area is pointing to point this point. Okay. Okay. So if you will like write like this, then you will get 24. 6 into 4, 24. Okay. So if you want to see what's inside your prototype, sorry, the instance will not have any prototype. Okay. So you can see, if you want to see prototype, you will see with help of this one. Okay. So you can see the prototype has this add value. Okay. X and Y and a constructor pointing to point 3D. Okay. Your object will be have only, see, if you will have an instance of any function, okay, then you can get the prototype like this. Okay, so you can see this is pointing to point. Okay, so it is pointing to point one point. Okay, and here you can see if you have again this prototype chain, then you will get area. Okay, now if you will have this, then you will have object. So this is the prototype chain. Okay, so this is the prototype. Okay, and if you will write it here, and if you want to try with get area, what happens? You can see 168. So the thing is that here we are doing polymorphism. Overwrite. Okay, so what happening here? You have created the prototype. So you have replaced the prototype and we have defined this one earlier, that one. Okay. So now to achieve with these all, this constructor is now pointing to 3D. So this constructor will require three parameters. Okay. So if you want to get the output of all three, you have to write after this pointing of. Okay, so this is the example of uh, pseudo classical type in which we have a point as a parent function. Then we have an prototypal method here, okay, inside point, so that each instance of point will get automatically this get area, okay. And we have a class child point 3D, okay, which calls the parent one inside this to get these two property inside this, okay, inside this scope. And we have z separately, and we are overriding the add method of point. Now what we are doing this because we were not able to access this get area of parent one, okay. So to achieve this, we used this prototype. Now if you want to have override your own get area with this get area, so you have to write after that one. We have used this constructor to point this point 3D constructor. Otherwise, if you not write this, this will use the constructor of this point. So what we have seen, we have tested with this, okay, that before doing this, it was pointing to the parent one and giving the output of only 2. But after adding this and after overriding this, we were getting the value of all 3. Okay, so this is the simple example of prototype pseudo classical inheritance. Okay, now what we do, we will erase all these things. Now it's in simple, we have okay, now in simple we have a parent class, prototype in parent, and a child class. Now we will use the prototypal second type. So to achieve this, we use the object dot create to create a new object. Okay. Without prototypal, we use the pseudo classical in which we have used the new and class name. Okay. But in prototypal, what we have to do, we will use the object dot create. Okay. To get the new object inside the prototype. So for that, what we have to do, point 3D dot prototype equal to object dot create, and here you will have to write point dot prototype. Okay, similar thing happening, only we have replaced this with new. Okay, new point. We have replaced this with object dot create with point prototype. Okay, now what happen if you will have let d equal to new point 3D, and we have some value. If you will console.log d, what you can see, it is pointing to directly point. That means again this is pointing to your point constructor. That means parent constructor. So d dot constructor. If you will write the d dot constructor dot name, then again you will get the that whatever the constructor you are pointing on. Okay. So what can you do to achieve you have to do constructor equal to point 3D. Now your constructor will point to the on constructor. Okay. If you don't want to use like this here, you can simply use Okay, that means if you will do like this, you will get pointed to this one. Otherwise, if you have don't, then you will get to point. So this for by using this, you can also bypass this line. Okay, now your D constructor name is point 3D. Okay, so now if you will call the add, you will get 6 plus 5 11. Okay, now what will happen if you will want to access the get area? You are getting 8. That means 4 into 2, it is returning. Okay, so now what will happen if you will have a prototype override here with point 3D. So this dot x z. Now you are getting 14. Okay, that means 4 into 8 and 8 into 5. So this is the mm, type of prototypal in which we use the object.create to set the prototype chain. Okay, if you want to set with the constructor, see, this prototype exists only with your method, if you will call this class method. Okay, but this will be with your instance, like you have used the instance. So the instance will have okay, a prototype will have proto and a constructor. Okay, that means what we are saying that inside prototype you will get two things. You have a proto and you have a constructor. Okay, so this is the thing. Now we have two types discussed. Okay, now the third type is parasitic inheritance. Okay, so similarly this is the thing, and we have to remove this one. Okay, now this all the thing is there. Okay, now what you will do, if you want something, okay, here you will have let that equal to new point parent one and with value x comma y. That dot z equal to z, and that dot, if you want to override something, that dot add equal to function return that dot x plus that dot y plus that dot z, and again return that. Okay, now what will happen, console dot log let equal to new point 3D with some value, and we will have the, you can see you are pointing to the point, that means parent one, but you have value of x, y, and z here. If you want to add, what will happen, you are getting 3 plus 4 7 plus 5 12. Okay, that means you are accessing x comma y from the parent one and this one as well. Okay, so what will happen if you will call this get area? That is 12 again, because it is giving the multiplication of this. Okay, 3 plus 4 plus 5 was 12 as well, but 3 plus 3 into 4 is giving to the get area as well. That means here you are able to access this one as well and inside one as well. Okay, so you can use, okay, this one and this get area as well inside this one. Okay, so this type of inheritance is called parasitic inheritance. Okay, this is the third type. Now we will come for the last one, which is the ES6 feature, which is with the class. So this is the easiest one. Okay, let's suppose we have a class point and we have a constructor here. Okay, x comma y, this dot x equal to x, this dot y equal to y. Okay, now we will have a method here add, and this will return this plus x plus this by y. Okay, now we will have another method which will inherit this at point 3D. We have a constructor to get x plus y plus z, and here z will be used, and you will have to call the superclass, that means parents constructor here, and we will pass the x comma y because this will need only 2. We are passing the 2. Okay. Now what you want, if you want to override this, you can use this one, this plus x plus this dot y. So we have done. Okay, and now time to use the inheritance. So how can we inherit? We will use the keyword extends and we will give the name of parent one. So now our work is complete. Now let b equal to new point 3D some value and console.log p. So you are pointing to point 3D, but you are getting x comma y comma z, all three value. If you will have here, you will get, you are pointing to the parent one. Okay, that means your chain is pointing to point 3 is using the inheritance of point 1. Okay, now if you again this have this one, then you can see you can have object here. Okay, now if you will use add, you will get the value. Okay, sorry, this should be z. Okay, now it's true. Okay, so this is the classical type, means class using the class with the help of extend keyword, which was introduced in ES6 version. So this is the simplest way without any issue. Okay, so in summary, what we have learned today, we have used to how can we use the inheritance. We learned how to use the inheritance in JavaScript and also with the class. Okay, so in pseudo classical, we used the new class. Okay, and in prototypal we have used the object dot create with the help of class dot prototype. Okay, and in parasitic inheritance, what we have used the that. That means inside this one, that equal to return that, okay, which is equal to the new parent class. Okay, and in this one we have used the extend keywords. So this is the summary of this inheritance inside your JavaScript. So thank you for watching this session and like our video and subscribe this. Share this video with your team members so that you can get easily on the inheritance, and subscribe our channel so that you will get notifications of upcoming videos on JavaScript. Okay, thank you for watching again.